Now I will start with the last part from chapter 3, which is you're going to find it under chapter 2C, one-dimensional kinematics. And here we are going to talk about a very important example on like what we like call it one-dimensional constant acceleration motion. And I want you to check the video on the moon, okay? Just because I don't want to have my file large. Okay, and this is the reason why I'm asking, like I'm putting the videos outside the lecture so that you will be able to watch these and get the information. Now, what we have here is, I will say for sure, this is the Earth, and I have something here that is going to be pulled towards the Earth by what is called a gravity. Now, gravity is going to create an acceleration. We call it a motion. We call it free fall motion. Now, the free fall motion means a motion under the influence of gravity only. What does that mean? That we ignore here air resistance. Then it has been proven by all the scientists that near the surface of the Earth, and regardless what the mass is, all objects accelerate towards the Earth by a constant rate. And that it is negative 9.8 meters per second squared. Why it is negative? Because it is towards the center of the Earth, which means for us it is downwards. Now, of course, if we will move away from the Earth, that number is gonna be different. Then I will say we are really here. We are going to have it like very close to the Earth, which means we will not have changes in the value of that acceleration. Now, therefore, the equations that I did use before, I can use them again. And these are the final equals VI plus AT, V final squared plus VI squared plus 2A. And now I'm going to say Y because I am, Y final minus Y initial. Okay, I don't want to change the notation. And Y final equals Y initial plus VIT plus 1/2 AT squared, and Y final equals YI plus VI plus V final over 2 times T, and A always, it is negative 9.8 meters per second squared. Okay, now here I will say I'm gonna solve for you a problem that is gonna be about free fall. Then I'm gonna say this is example 1. We will do the same thing that we did with constant acceleration motion. Okay, and I'm gonna use also the one from your textbook, a person standing on the edge of a high cliff throws a rock straight up with an initial velocity of 13 meters per second. Thirteen 0.0 meters per second. The rock misses the edge of the cliff as it falls back to earth. Now I want to do the following. I want to calculate. I don't know why it is changing into an eraser. Okay, the first thing I want to have it is calculate the position Okay, I don't want to do all. I will say at 2 seconds and 3 seconds. I will calculate also the velocity at 2 and 3 seconds as well. And here is the solution. I am on top of a cliff, or I am on top of a building. Okay, and I will throw the thing up. It's gonna go up and it's gonna go down like this. I like always to have here my origin. To have my yi equals 0. Okay, and just what I have here is I'm gonna have my box here. And I will say here, I have VI 13. I have a negative 9.8. I'm looking for the calculations at t equals 2 seconds. And I'm looking for y final. And that is my initial, it is 0 meters. Now, if I look at the, I will say the, equations that I have, I will say that I have what? I have the equation that is gonna best here is y final should equals y initial plus, okay, yeah, I did, so yeah, the position. Okay, VIT plus 1/2 AT squared. And that is going to be the y final equals 0 plus VI is 13. And time is 2 seconds. And this is the acceleration. And from that, what I can say, y final is going to be calculated here. And I can find that it should be, the position here, it should be 6.4 meters. Now I can calculate now for the velocity. I have my initial. I don't want to use anything from like the calculated quantities. And the time is 2 seconds. A is meters per second, negative 9.8. And finally, I'm looking for V final. Then the best equation here and the easiest is V final is going to be V initial plus AT. And from that, I can say VI, it is 15 meters per second plus negative 9.8. T is 2 seconds. And from that, we will be able to find that V final is going to be negative 6.6 meters per second. We can repeat that for T equals 3 seconds. And you will find that the position or Y final is going to be negative 5. Then it is going back to the earth. And V final, it is negative 16.4 meters per second. Like I can easily graph it. Like I can put more points, and just I'm gonna give you the sketch for that. Is gonna be something like this. And that is position versus time. Now for the velocity, we are going to have it go in like two velocities. Is gonna be positive and then negative, and this is the velocity versus time. And finally, for the acceleration, of course, is going to stay constant at negative 9.8. Now, I will ask a question here. What happens if the person throws the rock straight down? And just giving you like 30 seconds to think of it. Okay, then now here, the only thing that is gonna be changing is VI is gonna be negative 15. And then you have to repeat your solution using that VI. The detailed solution is provided for you in the textbook. Okay, and this concludes the chapter, and thank you very much for listening. I will post this as well.